Good evening and welcome to Mr. Wilson Live. We're streaming from the Caribbean, and usually the show begins at 5:05 and we stream on a Wednesday, Friday, and Sunday. I'm just in from work, but of course the show has to go on. This evening we're going to be looking at codominance, incomplete dominance, and of course we're going to be doing a review or revision of the topics we have covered so far. For genetics, we have covered inheritance of sex, we have covered dominance, and we have also covered inheritance of recessiveness. Now we're going to be looking today at complete and incomplete dominance, and in the description you can find a link to the playlist for the many videos we would have done on genetics. This evening we're expecting that persons are going to share with us some questions, and as much as possible we are going to be answering these questions on the show. This is going to be a practical class, and we're expected to be here for at least an hour. To those persons who have been here early, might I apologize for being late, but like I already explained, I go to work on a Friday and I have to act back in to catch a class, and I can't have a later show, or as the persons in Guyana and Trinidad will be disenfranchised. So as such, I have to try to squeeze it in to get here. So welcome to the show. I'm happy that you're here. It's another Friday evening. I'm seeing Barnett. She's always here early. Good evening. I'm seeing Anderson, and Anderson is also here early. I'm seeing Macmillan here early. Abby Penado here early as well, and Miller is here early. How wanna do? Una all right? How has it been so far? How the studies? Talk to me in the chat. Tell me something so I can start the ball or roll. Tell me something in the chat. What's happening? Are you guys fine? Yes, no, it's good. We're not asleep. I'm hoping that we're not. All right, one other thing about codominance, when we talk about codominance, I like to say that the phenotype is pretty much shared physically in the offspring. I like to say that. That's pretty much how I tend to give my students it. So what I'd say to my students is that very good, guys, very good. Yes, I am doing wonderful, wonderful. What I'd say to my students is that pretty much if we were supposed to mix red and white, and we had two cattle, and we are looking at what the offspring is going to be, let's use black and white. If we're supposed to mix black and white, then for codominance, the offspring would come showing a little black and a little white, and it's like the Dalmatian pup type of thing, where you'd have both colors being expressed in the offspring. That's pretty much codominance, and we're going to be going through codominance. Do we understand that? So in codominance, both allele from the parents is expressed in the phenotype. So if we're supposed to mix a black cattle, a black bull, with a white cow, then the offspring, the calf, would have both black and white. That's codominance. Are we fine with that? Remember, I'm telling you that all these crosses are pretty much the same. There's a rule that is different. So you must be able to understand what I'm saying. I'm going to be starting the class with the revision, and I do hope that you have some questions there to share with me. So that's it for codominance. I'll say it for the last time, or I'll say it again. Codominance, the allele for the particular trait will cause the trait to be expressed in the offspring. And that trait we're talking about is a trait from both mother and father. So you'll be able to physically, or you'll be able to see it. So if we mix black and white, we're going to get an offspring that has both color. Cool? Now I'm going over now to incomplete dominance. Incomplete dominance. Please listen to the rule. With incomplete dominance, and there are some teachers who teach codominance and incomplete dominance as the same thing. They say they are both incomplete dominance. But I try not to teach it like that because there's a little variation. With incomplete dominance, a new phenotype is formed. With incomplete dominance, a new phenotype is formed. So let's get back to our cattle. Being that a new phenotype is formed, we had a black bull and a white bull, and created an offspring. We call the offspring a calf. Tell me in the chat, what color the offspring will have? We are talking now about incomplete dominance. And with incomplete dominance, a new phenotype is formed. Anika Martin commented. What color will be the offspring? Oh, Dana Folks is in the building. Hey, Dana, how you doing? Welcome to the show. Dana is out of the block and she's out with some amount of force. She's saying gray. Anybody else has anything else to say? Are we in agreement, disagreement? A new phenotype? If we were supposed to mix black and white, would gray be a new phenotype? Talk to me, somebody. I need some help here. I can't manage alone. All right, so we mixed black and we mixed white, and we're looking at what the new offspring will be. And this is incomplete dominance. Incomplete dominance. All right, so a number of persons are saying gray. Perfectly well. With incomplete dominance, though a new phenotype is formed, that new phenotype will be that of both parents, mother and father. That mixture there producing something new. So if we were supposed to mix red and white, what would we get if we are looking at incomplete dominance? Now let me see where my lesson goes this evening. All right, so we're mixing. Just tell me in the chat there what would happen, red and white. What's going to happen? What will happen? So we mix red and white, we're going to get pink. All right, so I did say in my description that I'll be looking at blood group. And interestingly here, I usually say to my students, I look at a lot of books. I'm looking at a book published by, I won't drag the author down, but I'm looking at two books that are that were published by the same publishing house. I don't have all the book here, but these are two books that were published by the same publishing house. And they are looking at the same thing. And they say something totally different about the same thing. And these are two books that are recommended for CSEC. Two books. I have one over here, and I looked at it, and I looked at another one. One is for HSB, one is for bio. The book that is for bio explicitly states that the ABO inheritance is codominant. The book for HSB states that it is incomplete dominance. They were published for the two exams. Who is correct? All right, I feel like I should get the other book to even see if it's the same author. But I'm not here to hit anyone, but it would have been easier on the students if both books came out with the same thing. It wouldn't cause any confusion. So that's where I think teachers come in, where we have to settle the deal. All right, so let us get into this thing now. Do you have any question there for me? Any question? If you have any question there. Okay, there's a question there for me. All right, beautiful. All right, the question here from Miller. I thought it was red and white. Now, red and white is going to be associated with codominance. If it is incomplete dominance, then a new phenotype will be formed. And that new phenotype, of course, is going to be pink. That new phenotype is going to be pink. All right? However, if it is codominance, then like you have said there, Miller, the offspring will be red and white. Are you with me? Beautiful. So we're going to get into the mix of things. I want that to just settle with you. And then I'm going to be writing some questions. Last time I left you with some stuff, but I am like reinforcing this genetics thing. So every time I come to class, I go backward, then I go forward. I go backward, then I go forward, because I want to ensure that you have it all locked pat. I've been seeing some of my kids, and they are saying, "Sir, we really don't have it all as yet, you know." So I decided that, you know what, we're going to get this. So after we would have completed codominance and incomplete dominance, I have a video on test cross, or what we call back cross, but I will do it next show. And then we have to look at the pedigree chart. Now, before we look at the pedigree chart, I'm going to be releasing a video, because I realized that in the textbooks for CXC, the pedigree charts are not well explained. The books that I have seen, the many books that I have seen, they're not well explained. So what I have done, I have put together a little thing to send to you on the pedigree chart. It is way advanced. And having done that, then when I release that, I'm going to release the video on Tuesday or Thursday. Tuesday or Thursday, the video will be released. And once the video is released, then you need to watch that video, so that when you come to class and I give you this big diagram to solve who have what, you are able to solve it. But before we can solve who have what, we must have all these well, we must understand all these really well. We must understand inheritance of sex. We need to understand sex-linked inheritance. We need to understand inheritance of recessiveness. We need to understand inheritance of dominance. We need to understand incomplete dominance. We need to understand codominance. You understand why we are having this practical session? You understand why I keep going left and right? All right, beautiful. I am ready to start now, because everybody is here. So those persons who are in yonder land, did I say good evening? Good evening to you all, and welcome to the show. Please be reminded to like, share, and subscribe as we go right ahead into the mix. I'm going to start the evening with the easiest cross, which is inheritance of sex. So let me just give you that. Get your pen and paper out. It's a practical class. So I am seeing some wacky things on the internet about how many children persons would have had, and some persons are saying that it is true, and some persons are saying that it is not true. But a woman would have had probably 69 children, and a lot of them being twins and triplets and probably quadruplets, that type of thing. What is the likely chance of that woman having a girl the next time this woman should conceive, or the next time the woman should give birth? Now, I want you to show me the genotype of the offspring. I want you to give me the phenotypic ratio, and I want you to explain to me why your answer is it is. So I want you to do that quickly, because you guys would have mastered this. Now, just a reminder, we use the chromosome XX to represent the female and XY to represent the male. Good evening, Audrey. So go right ahead now. Answer that for me very quickly in the chat so we can cover everything within an hour. All right, just reach home from school. I see it happens every now and then, Paul. All right, are we ready? So we're looking at sex determination or inheritance of sex, and we want to know what will be the sex of, what will be the phenotypic ratio of the offspring after a woman would have given birth to 69 children. What are the chances of her having a girl the next time she should give birth, or she will give birth? Go ahead with that for me and let me see how we can treat with it. Please don't take too long. Please don't take too long. All right, so we're having a practical class. So I am waiting on the students to respond to a question I asked. Now, the phenotypic ratio, no, Barnett, that is not the phenotypic ratio. That is the genotypic ratio. Remember, once we are dealing with the letters, that would be genotype, right? When we are dealing with the phenotype, we are naming something. Tall, short, fat, slim, brown, boy, girl, hemophilia, cystic fibrosis, albinism, sickle cell anemia. All of those are phenotype. But once we're working with the letters, then that is, of course, the genotype. All right, Smith, good evening and welcome to the show. I had watched a lot of videos, but never really log on to the live before. Welcome to the show. And you get the Mr. Wilson dance. It's a consistent thing once you're new. All right, welcome to the show. And we want you to come back, Smith. Usually we know the persons who are new because everybody know each other in here. We're here every week, 3 times for the week. So we tend to know each other. All right, very good. So there you go, Barnett. That's good. So the phenotypic ratio here would have been 1 male to 1 female. You can't write 1 to 1. All right. And I observe other persons are not answering. Welcome. All right. Thank you very much, Pinedo. Pinedo is welcoming Smith to the show. We're very happy you're here. We're starting off slow, and everybody know my energy. If you're not answering, I don't have energy, no energy to work. Right? So even if you say I don't know, it helps. But if you are just there not saying anything, it's like I don't know what to do and where to go. All right. So you must answer when I ask a question. If you don't know, you don't know. Not everybody will know. If you knew it, you wouldn't be here. All right. So you have not answered the question. So it means that I have to go right back through that. And I'm going to just be doing that one time. So the first thing we want to do when we are doing any cross is to name the parent or the parental phenotype. I like to talk about the phenotype. In this case, it's going to be male and female. All right. So that's the first thing you're going to do. Name the phenotype. Here it is male and female. After you would have done that, you are going to name the genotype. Now, the genotype refers to the letters that we use. It's a consistent practice that we use XY to represent the male, and we use XX to represent the female. So this is the next step. Now, after we would have done this step, then the other thing we need to write is tell me in the chat there, tell me in the chat after we would have written the phenotype, then we would have written the genotype. After the genotype, what else should we write? Okay, Martin, welcome. What should we write after the genotype? Let me see if we are remembering. Guys, once I get to the pedigree chart, all right, very good. So we are going to write the gametes. Now, what makes the difference between the gamete and the the genotype when we are writing it? What is it that we do to make the difference or to indicate the difference? No, we're not at the Punnett Square. I see you are new. I don't know. I see. Welcome to the show, or if you're using another name. I'm not seeing Jawawan. I am not seeing Tanisha. I'm not seeing Otisha. I hope they are fine. I'm not down with COVID. All right, very good. So the gametes. All right. So you could write that out in sentence. What we do. So now we have the chromosomes as they are here now, and you observe they are very close. Now to write the gamete, all that we do, I'm using an arrow, all that we do is to space them. So this would have been X and this would have been Y. So there it is, we would have spaced them. Now outside of spacing them, I could have also written them like this, X in a bracket and Y in a bracket, and these two could represent the gamete right here. These two could represent the gamete. So we could write it like this, space it like that at the top there, or we could write it like this here at the bottom. So we're going to be writing the gamete just for the female just the same, and that's going to be XX all spaced. All right, or I could put X in bracket and X in bracket, and then you must make sure that you are doing your labeling on the side. So the parental, phenotype, genotype, gamete. Now, once we would have done that, then it's time for segregation, or what we call random fertilization. Now, if we're drawing the lines, that's pretty much the same thing. But for me, and for persons who are going to be doing further biology, the line is good, but the Punnett Square is better. Because when we're now doing monohybrid inheritance, so we're looking at one trait. But there's dihybrid inheritance where we're looking at more than one trait. And then there's trihybrid inheritance where we're looking at, see what happens? So what happens is that the Punnett Square becomes bigger, the lines become more, and the confusion become greater. So we don't want to go there. So we practice both. So we're going to be doing the Punnett Square today. So what we do, we draw a rectangle for the Punnett Square. I think you guys are going to be perfect for genetics. I've never spent so much time teaching genetics. So draw a rectangle. Then we draw two horizontal lines. And these two horizontal lines, they are drawn in the rectangle. All right, you might see other diagrams online, but this is the easy one for me. And then we are going to be drawing two vertical lines. There are some new persons here, so just be patient with them. Two vertical lines. So we end up with a grid looking something like this. Then what we do, for those persons who still didn't get it the last time around, we are going to split the first cell diagonally. There we do it. There it is. And then we're going to indicate which is male and which is female. Now, if you can't remember these fancy symbols, that 0 with an upside down arrow attached to it, which represents male. If you can't remember that that represents male, write the word. And if you can't remember that a 0 with a cross attached to it represents a female, write the word. In this case, it's very important for you to note which is male and which is female. It doesn't matter if you put the female at the top or you put the male at the top. Seriously, it doesn't matter. All right, you could put it whichever way, but just make sure that it is well labeled. Let's move right along. So being that we have the male at the top, then it's only fair that we write the gametes in X, Y. All right, that's for the male. And we are doing inheritance of sex for the last time. And then we're going to write in the female, which is X and X. That's the female for the last time, X and X. Now we're going to be doing the cross. Thanks so much, Miller. Now we're going to be doing the cross. Wherever they intercept, we're going to be writing both in the cell. So this X would intercept this X here, so we're going to write them both in the cell. So here we go. X, X. They are both written in the cell. And then X and Y would intercept pretty much here, and we write them in the cell just the same. And then we move right along, X and X intercept, and we have that. And then we have X and Y, and we have that. Please be reminded that you can just press print screen, and whatever is there will be printed, and you could write it in your book thereafter. So if you think I'm going too fast, I'll hold it up quick enough for you to just press print screen if you are using your computer, and you can paste in Word, PowerPoint, whichever. All right, beautiful. So here, we are expected to represent this, if we're talking about genotype or phenotype, in its smallest form. So here we would have 2 females as offspring, 2 males as offspring. So this pretty much 2 into itself go 1 time, 2 into itself go 1 time. So it would be 1 female to 1 male. All right, that is how the calculation, Barnett came up with the calculation. Okay, if you go to if you look in the description for the live, you'll see a link to the Punnett Square. The Punnett Square is that diagram that we use to solve these genetic questions. Right? I don't know if you are new. This is a different Martin than our regular Martin. Are you new, Martin? Genesis, are you new? If I have Zoom, Campbell, are you new? Yes, no, it's fine. I don't know. I don't know. All right. There's a question about Zoom. We're going to be having some paid classes for those persons who want to be a part. We're still going to have our free classes, but we're going to be having some paid classes. If you have interest in that, you could just send us a mail. Go to our channel. Only serious persons. If you are not serious, don't even come and query. That's fine. You still can stay over here and learn something. All right. So if you want that information, you can see us. Wedderburn, good evening. All right, so yes, I have a video on the channel, and there's a video there. Okay, not about it. All right, so if you have no money, then you stay on the free. Anything you want in the class, please just ask me over. Use the email address to ask. All right, so here we have it. Good. All right, beautiful. So we move right along, and I should have. Well, I think this is all well solved. I'm going to give you another question. A lot of person didn't take part in that one just now. So I'm going to look at PTC again. PTC is a chemical that only some persons can taste. If you have the dominant allele, you're able to taste. If you don't have a dominant allele, then you're not able to taste. Now, you're going to be crossing a parent that is heterozygous for tasting PTC versus a parent that is homozygous recessive. And I want you to tell me what the offsprings will be in the chat. Remember, this is a practical session, so you do the work, give me the answer, then I work it and show it to you. All right? So we're crossing persons who are heterozygous for tasting PTC, and we're crossing a heterozygous parent with a homozygous recessive parent. Tell me what the offsprings will be. So the first thing we're going to be doing, we are going to be constructing our Punnett square to solve that question. It's a rectangle with, of course, 2 lines coming down, 2 vertical lines and 2 horizontal lines going across. That's in the rectangle. And then a diagonal line in the first cell. All right, we are doing genetics. Hi, Amoy, how are you doing? All right, so Amoy, what I'm saying, we are doing a little revision to get into codominance and incomplete dominance. The whole idea is that we're going to be doing pedigree chart pretty soon. And because we're going to be doing the pedigree charts very soon, we must understand this. I teach both biology and HSB. This class is for both bio and HSB. All right, so we want to cross now parents who is heterozygous for PTC, and this is inheritance of dominance, with a parent that is homozygous recessive for PTC. So I want you to solve for me and put it in the chat. So one parent is heterozygous, and we're talking PTC here. We're going to be using, we could use capital T. You could define the allele to be capital T for the tasters and common T for those persons who can't taste. Campbell, is this your first show? All right, so I wait on you to respond. My Punnett Square is all drawn. I tend to do the shortcut. I would have shown you the correct way to do it for your question 2. So that way that I showed you with the parental, phenotype, parental, genotype, gamete, then segregation, that is how you are going to answer your paper 2 question. But when it gets to the multiple choice where you are answering the question there that comes somewhere between 40 and 60 thereabout, you are going to just do the shortcut with the Punnett Square to answer. Let me just find, I've been trying to find one for you. I don't know what's been happening. Guys, remember you're supposed to give me, so Amma, you're here, so I'm going to need some genetic questions that probably you guys want me to treat with. All right, do we have answers for that as yet? All right, Amma is out of the block. So Amma is saying that, and Barnett is saying that. So one of the parents is heterozygous, and one of the parents is homozygous recessive. So we're going to get that, and we're going to get that, and we're going to get that, and we're going to get that. All right. Anybody else with anything else? Any other answer? Anybody with any other answer? All right. So Powell is here. Any other answer? All right. 3 persons would have responded. All right. I see responded. All right. I see. Your first thing here is IT and not TT. You probably want to look at that. All right. Anybody else want to respond before I go ahead with whether it's right or wrong? Any other response? Any other response? All right, got to go. All right, this is so correct. What's going to happen? When you solve, it will look like this. And this is the way that we solve for the multiple choice. This is not the paper 2. For paper 2, you'd have to write out everything. So there we have it. Good. So the answers that we have here, they are all correct, except for the first thing that IC has there. Beautiful. Now, there are many other things that we could do for inheritance of dominance. Yes, Pinedo, many other things, and I suggest that you practice them. But we're going to be looking at all, so we have to go through very quickly. I'm going to be doing one more for inheritance of dominance. All right. So listen to this very carefully. A homozygous dominant parent would have been crossed with a homozygous recessive parent. What will be the offspring? What type of offspring? Give me the genotype of the offspring. Now here, we are looking at offspring, and the phenotype for these offspring given here is that capital T, common T, that person will be able to taste. Because once the dominant allele is expressed, then the individual will be influenced by the trait. Then the 2 common T's that this individual is not able to taste the PTC. In order to taste the PTC, you would have to acquire the trait in its homozygous dominant form, that is the 2 capital T, or the heterozygous form, which is a capital and a common. So when we say heterozygous, it's usually capital and common letters that we're using, depending on what we're looking at, because when we get over to blood group, it's going to be a little different. All right? All right, good. So Amma is understanding. Amma, watch the videos. Amma, watch the videos. Amma, watch the videos. Amma, watch the videos. Look at that. Amma, you watch the videos, yes or no? Amma, did you watch the video? Or the videos? Heterozygous, no. We don't have any carrier for inheritance of dominance. The term is not used with inheritance of dominance. Not right. We just say heterozygous. You didn't? So Anmoy did some work on her phone because she's back strong. All right, beautiful. All right. So Amoy wasn't able to cope in the last class, but she's out of the block and she's doing pretty well. And I'm assuming the other persons are doing well. I paid attention last class. Okay, Amoy. You're coming strong at me though. All right, beautiful. So one thing I want to point out, and I'm saying this very, very early. I'm saying this very, very early. It might be a little too early, but just remember, once the dominant trait, as in that homozygous dominant trait, is expressed in appearance, when you get to the pedigree chart, dominance will not miss any generation. All generation will have the dominant allele. All right? Whether the heterozygous form or the homozygous form, it won't miss any generation. And we'll soon get to that. You will have to watch that video because, like I've said, it's a little more than what is in the CXC book, but I think you need that to pretty much understand. All right, so we just looked at inheritance of dominance. We looked at inheritance of sex. We're going to be looking at inheritance of recessiveness. And we talk about recessiveness. Some common things we could think about is cystic fibrosis, albinism. These are recessive traits, right? What it means, in order to acquire them, you must acquire them in the homozygous recessive form, which means that two small letters are two common letters. I keep saying letters because our students, probably the allele thing is sort of too much. So I keep saying common letters because you can learn what you have seen. All right, beautiful. Here we go. So we're looking at a recessive condition. So now we're going to be crossing a homozygous dominant individual with a heterozygous individual, and let us define the allele to be capital A for dominant and common A for recessive. What is going to be the genotype of the F1 generation? If you're just joining the class, we would have done this a couple of times already. Volume 44, 5, 6, 7, all are looking at genetic practical. And also in the description for this live, you will find a playlist or the link to the playlist for the genetic diagrams and animation for all these genetic live that we have done. We don't have a video out as yet on recessiveness. We don't have a video out yet on codominance, but those will come soon. All right, so I'm always asking me to repeat, sir, how to go. So I have to go on the road. All right, that's fine. No problem. All right, I'm saying we are looking at inheritance of recessiveness, right? With inheritance of recessiveness, in order to display the phenotype for the particular condition, then you must acquire the allele in the homozygous recessive form, and that means two of the common letters. Now we define the alleles to be capital A for dominant and common A for recessive. Remember that we always have to define the alleles if they are not defined by the exam paper. So now we are crossing these two individuals. One is, anybody want to remind me? I know that one was, anybody want to remind me what it was? I'm not looking at a script. I am just giving you from my head and hopping right along. All right, no one remember, I'll just tell you. So we are crossing a heterozygous. Let me start with that heterozygous. Let me write it down. We're crossing a heterozygous individual with a homozygous. We're crossing a heterozygous individual with a normal individual. So we're crossing a normal individual with a heterozygous, and we're talking about normal. This person is homozygous dominant with a heterozygous individual. What will be the genotype of the offspring? All right, do we have that? Anybody else with anything? I don't know. It seems like the persons are not understanding. It seems to be such a difficult show. I don't know why. All right, so Barnett is out of the block, and Barnett is saying that it's going to be the genotype there is 2 will be homozygous dominant and 2 will be heterozygous. 2 of the F1, 2 out of the F1 generation will be homozygous dominant and 2 will be heterozygous. Now, Barnett, all right, cool. This looks a little better. At least 3 persons. We have 3 persons in the class. Another thing I'm going to be looking at now. All right, Mackenzie's here as well. Beautiful. Beautiful. Yes, that's correct. Beautiful. That's all correct. All those are correct. No. Nicola Thompson? No. We're looking at a homozygous dominant and a heterozygous individual. So you wouldn't be getting one of the offspring to be homozygous recessive. I see no. That is wrong. That is wrong. I'll show you. What we're crossing big A, little a with 2 big A's. So you are supposed to get something looking like that. All right. So let us revisit that to have that corrected. So if you, Barnett answer is correct, Lawrence answer is correct, Folk answer is correct, Mackenzie answer is correct, Thompson, I suggest that you revisit. I suggest that you revisit. Anderson, your answer is also correct. All right. So what's the phenotype of your offsprings? Tell me now. What's the give me the phenotypic ratio for your offsprings now. So you have just given me the genotype. Tell me the phenotype of your offsprings now. Phenotype of the offspring. Phenotype of the offspring. All right, so right as we would have completed that, we're just going to up on over into sex link, because remember, it is just pretty much repetition. All right. Looking at your answer. All right, so we're ready to go. Let me see what's there. So, all right, just let me treat with this here. The phenotype here is not heterozygous, neither is it homozygous, right? Now, to give me the phenotype, you'd have to tell me if a person is normal, carrier, or if a person has the disease. Those are going to represent the phenotype. All right. So when we use the homozygous and heterozygous, we are referring to really the genotype. All right. So when we talk now about those who are normal versus those who are carriers, versus those who are affected by the disease, then there we are talking about the phenotype. All right, and in that case, it would have been 2 normal to 2 carrier, which can be expressed as 1 to 1. All right, so the ratio there, 1 to 1, 1 normal, 1 carrier. All right, that's going to be the phenotype there. All right, please be reminded that you can revisit the videos that I've done already. So now I'm going to be looking at sex-linked inheritance. Now, with sex-linked inheritance, what happens is that the trait is carried on the X chromosome. Now, sex-linked inheritance is also called X-linked inheritance. There's also Y-linked inheritance, and if we say Y-linked inheritance, it only affects the male. Now, one of the reasons for the trait being on the X chromosome only is because the Y chromosome is a little shorter, so it's not affected by that trait. All right, or the trait that cannot be attached to it based on the size. Now, this becomes a little more challenging, or as it becomes a little more challenging as we are now looking at 2 things instead of 1. So we are looking at both the sex of the individual and the trait that the individual is affected by. Now, some of the things that we can recall, and the popular one for your syllabus is going to be hemophilia and color blindness. Those are popular for sex-linked trait. And bald head is not on the syllabus, but that is also a sex-linked trait. All right, beautiful. Thank you very much, Barnett. All right, so now we draw our Punnett square, and by this, I think everyone can draw a rectangle with 2 horizontal lines in and 2 vertical lines, with the first cell is split in diagonal. So in this case, every time there is inheritance, the inheritance is either going to be male or female, with or without the trait, or carrier. So it can be a female that is affected by the trait, it can be a female that is a carrier, or it can be a female that is not affected by the trait. For the male, it can only be affected by the trait or not affected by the trait. All right, so here we go. So we're going to be crossing a female carrier with a male that is affected by the trait. A female carrier is crossed with a male that is affected by the trait. Not now. Not really. All right, so we are now crossing. I think some persons are like really taking a hit. I think you have to watch the videos. I suggest that you watch the videos because you would have passed this area long ago. So you want to ensure that you are familiar with what we're doing by watching those videos. As we are going now into, I'm going to be doing codominance. And once you would have mastered the crossing, then teaching your codominance and incomplete dominance is very easy, because after you would have completed pretty much crossing with sex-linked inheritance and you're working with 2 things, the same is true for all the others. So that is why I would have built up the lesson the way I did, moving from one thing to another, and it became a little more complex as we go. I'm having a little headache, but I'm fighting to go to the end. All right, so here we go. So we crossed, what did we cross? Who did we cross? We crossed a female who is a carrier, and it's hemophilia why persons are using H, but they know that I didn't say that. So we're looking at hemophilia here, and the allele is defined as H. Most persons would have done this already. And we're looking at a male that is affected by the trait. All right, so when we put that in nicely, we are going to be moving both letters at the same time. We don't want to move the H alone and leave. We don't want to do that, all right? So we are moving both letters at the same time. if you would have seen an exam paper like the question Amoy gave me the last time around, you might see something on the Y, but ignore it. Because what we are doing is X-linked inheritance, so we really don't care about what is on the Y. All right? Not for now. So we're crossing. Let me just see if what is there is correct. We're doing sex-linked inheritance. And one of the problem with this is that at the end of crossing, you will have to tell whether it is male or female, and if the individual is affected by the disease or not affected by the disease. And that makes it a little challenging for a lot of persons. All right, so I'm looking here. I know Barnett is out of the block, and Barnett has Barnett, you have to revisit, and let me see. You have to revisit. Why you have to revisit? We are crossing a heterozygous female with an affected male. So it's we are crossing a carrier with an hemophilic male. We are crossing a carrier with an hemophilic male. Now remember, you can only have one H when it comes to the male, because remember the allele is on the X chromosome. While in the female, if it is a carrier, if she's a carrier, then she's going to have a capital H and a common H. All right, so the female is going to have a capital H and a common H. So that which you have solved here is not correct by my thing here. It should have been, let me see what you have. One normal female. No, it's one carrier female. I have one carrier female. Then we have one hemophilic female. Then we have one normal male and one hemophilic male. That's the answer for that. All right, so your thing should look something like this. We're running out of time, so I am just going to be giving you now the inheritance of dominance. Inheritance of codominance. Oh, everything is all going upside down. I do hope that you would have seen that. It's clear. All right, beautiful. So that is out of the way. So we are now going to be looking at incomplete dominance first. Now, when we look at incomplete dominance, what you're going to find is that it is represented with a location, so to speak. All right, so you will see, like if we're looking at flower color, you will see like a capital C, and then you'll see the allele on the C. So for example, if we're looking at flower color and we were using, let's say red, so we'd have that big C written, right? And for dominant, it would have been 2 capital R, and for white, let's use white, red and white, would have that big C, and then would have the white. So pretty much it would have been written something like this. All right, so are we good with that? Beautiful. Now to cross this, we are going to just pretty much do the same thing as we would have done before. Separate, get the gametes, then we are going to move on down into the segregation and then the cross. Now I'm going to be going the shortcut way here, right? I'm going to be giving you a video on this one because it might be a little too much for you, but just split the box, and as usual you are doing C, all right, R there. I would have the gamete R here. I would have C, W there. I would have W here. So what we're going to be getting, so you would have something more like this. We are doing this for ease. All right, C, W, C, and the R. However, when we are now crossing, we are just going to use one of the C. So we're going to just carry across the C, and you're going to have RW, and carry across the C again, and you're going to have RW. Carry across the C again, and in this case, it's going to be RW. And usually, all the alleles here is written pretty much in capital for the incomplete dominance. We shouldn't talk about the others. So your result is going to look something like this. Right? So I repeated the C cell so that we don't forget the C's. But when I'm writing them back, I write only one of the C. I don't write two, I write only one. All right? So here, the offsprings would have been all heterozygous for incomplete dominance. So if it was flower color and it is red and white and it is incomplete dominance, then you are going to understand that this year all the offsprings would be pink. So I cross two heterozygous individual. I cross two individual, one that is dominant for red, one that is dominant for white, and this is what I got. You can just copy it if you so desire. Just look at it and copy. And this is popular among the plant that we call impatient. I don't know how many persons know impatient. That's where we experience or see a whole lot of the codominance. And the thing is the impatient that is on the syllabus. All right, so in this case, like we said, the offspring is going to be all pink. Everybody is going to be pink. Remember, when we are writing the results, though we wrote it with the C's here all around, top and bottom, we only write one C inside the middle here. All right, but I wrote the C's just to remember. You won't get everything this evening, but you'll get it as we go along. All right, so that there was incomplete dominance. Incomplete dominance. Now I'm going to be showing you codominance, but I am not going to be using flower color. I'm going to be using that which is on your syllabus and you are expected to see. So let's get into this. Start writing for me. You are going to have the letter I, which is pretty much the location or the locus or the position of the particular allele. So this first blood group represents blood group A. Now this blood group, I with AO, represents another blood group A. This is heterozygous, but it's A because A is dominant to O. So it's still blood group A. And then we have blood group B. And remember the I, all that the I does is to show the position, the location of the allele. Capital B, and the location I. And then we have the blood group now BO, and the blood group BO is still B because B is dominant to O. Then we're going to have blood group AB, and blood group AB, they are codominant. They are codominant because what will happen? They both will share. None is dominant to the other. However, we have blood group O. Blood group O. Blood group O is recessive, right? That is the recessive allele. When it comes to codominance, your recessive allele, when it comes to codominance, your recessive allele is going to be O. Now, before we get into the lesson, I know when we get into the lesson, a lot of persons will ask, suppose I have AB blood group and my fiance has ARB. What will be the blood group of the offspring? Will the offspring be AAB or ABB? No. What you must recall that only two allele can be present in any cell, unless it is some form of mutation. Only two alleles can be present in any cell. This is a rule that you need to know. So let me just give you the rules again for working with blood group. Please, guys, listen. This one appears on the paper all the time. Just let this bike pass, and then we're going to get it out of the way. A and B are codominant. A is dominant to O. B is dominant to O. You need to go and watch my video because your blood group could determine whether your offspring will have jaundice. All that is in the video, so you need to look at that video. Now, we're going to be doing the crossing. Remember that I that is represented there, all that it is for the location. So I like to say, just draw the Punnett Square again, and let's go. Just draw a Punnett Square. All right? Everybody can draw a Punnett Square now. Rectangle, 2 horizontal lines, 2 vertical lines. All right? We are crossing somebody with blood group homozygous dominant A with a person who is recessive, who has a recessive blood type. What is going to be the genotype of the offspring? And I want you to tell me what is the phenotype of the offspring. Go right ahead. We are dealing with codominance, and we're looking at blood group, and we are crossing blood group A, homozygous dominant A, with homozygous, I didn't say homozygous, we are crossing homozygous dominant A with the recessive blood group, or that recessive allele. All right, I'm having a headache. I'm not too sure what's happening. Are we ready? This is how we're going to be bringing down the current this evening with the ABO blood group. Anybody got it? All right, just like when you are doing inheritance of sex and you would have written the X and the Y and all of that, it's pretty much the same thing. You are going to be writing the I. So we have blood group I there with A. Blood group, we have location I with blood group A, and we have location I with blood group O. And then we're going to just write I, AO, I, AO, I, AO, I, AO. All right. So I didn't write male or female because now that just might be a little confusing. So this is what the offsprings would look like. We are crossing A and we are crossing O. So we end up getting A heterozygous. Now tell me in the chat, what is the blood group of this individual? What blood group this individual has? Tell me in the chat very quickly. We're 3 minutes over time. What is the blood group of this individual? Very good, I see. The blood group here is going to be A. All right, because A is dominant to O. So the blood group here is going to be A. All right, so another thing we're going to be looking at, we are going to be crossing now. Interesting. We're now going to be crossing AB with AB. Tell me what will be the offspring. What will be the phenotype of the offspring? And I want to see the genotype too. I mean, this one is going to be a little heavy for you, but you have to get the practice. We are crossing blood group AB. So we're crossing AB with AB. What is the likely? What will the offspring be? AB with AB. AB with AB. Oh, cool. I want to work that out for you. All right. So the parent is I, AB, I, AB. The gamete is going to be A, B, A, B. The cross is going to be A, B, A, B, A, AB, AB, BB. Interesting. What is going to be the offspring? Somebody say AB, somebody say B, somebody say everything that you can think about. Remember, to solve this thing, you need to, Amoy, did you write the gamete for this individual? Amoy, did you write the gamete for this individual? Try again by writing the gamete for the individual, and it might help you with the answer. I see is upping it and doing well. All right, so you are supposed to be getting an A, AB, and a B. All right, so if you solve it like that, yes, so it's going to be as Barnett has it there. So pretty much it is a blood group B, blood group AB, and blood group BB, AB, A. Yes. All right, so you're going to the gamete. Just let me just show you what I have, because these tend to give students a little trouble, some little problem when they get to the exam. So this is I just started from the genotype to the gamete and then to the segregation. So if you observe that this is done a little differently than we would have done all the others. All right, are we cool with that? All right, beautiful. That's pretty much how it is done. I am going to be revisiting this in the next class. So those persons who didn't get it as they should today, no need to worry. In our next class, we are not going to be looking at the other types of inheritance. We are going to go over codominance and incomplete dominance. We're going to be looking somewhat at the pedigree chart and try to solve some very simple problem on the pedigree chart as we get a little more. We're going to complete with we should be complete with the pedigree chart by next Friday, because I'll be giving you some practice with the pedigree chart with the days that we have left, Sunday, Wednesday, and Friday. 3 days worth of pedigree chart should be good. And then we are going to go into multiple allelism. All right. So that's going to be it for show today. Before you leave, make sure that you leave a comment. You're supposed to leave a comment after the show in the comments. How was the class? If it was good or not good. If you have not yet liked, share, or subscribe, you're supposed to do that. Like, share, and subscribe. Remember, for whatever blood group you are going to be doing, you want to write out the gamete like we would have written it here, and then the cross should be easy. So look at the top that I have there, IAB, and then when we write it out again, you want to write the I at the end, that's fine. So I could write it out as IAB, and that's the location, IAA, and then I could also write IAB again, just for you, and I could write IB. BB. All right, this should be good practice for you. All right, so we're going to be doing this again. So no need to worry. Watch the video, and when I get to the class, I hope we can find some exam questions on that, and I'll be treating with that. Please be reminded to leave a comment. All right, like, share, and of course, subscribe and give the channel some love. All right, there are many videos on the channel. I will realize that you're not watching the videos. We know when you watch the videos, you are not watching the videos. So make sure that you watch the videos and nicely complement the live. We are doing well. We slow down the class a little bit to do genetics because students are afraid of genetics. There are some things that you need to read on genetics that we did not do. All we did was a diagram. We might just give you a chart with the definitions one day, who knows? And that should probably help. All right. So thanks much for stopping by. Have yourself a wonderful weekend. Stay away from danger and catch you on Sunday. I might be traveling on Sunday. I don't know. All right. Take care. Good evening.